Good morning, all my dear friends. In last lecture, we have studied the main heading in the topic number 3, section number B. Its name is elasticity of demand. So, we have studied three main methods of measurement of elasticity of demand. Okay, so first method, how to calculate the elasticity of demand. So first, ratio of percentage method. Okay, so that method also developed by Dr. Arthur Marshall. Second method is total outlay method as well as total expenditure method. Okay, that types of method also well developed by well-known economics. We are going to start last methods of measurement of price elasticity of demand. Its name is, last method is point method. Which method? Point method. Okay, so point method is also known as, in your 9th or 10th class you have studied, point method is also known as geometric method. Okay, point method. So first method well developed by Dr. Alfred Marshall. Second method also developed by Dr. Alfred Marshall, and third point method is also developed by Dr. Alfred Marshall. Dr. Alfred Marshall. It's very simple. In every methods, you write the first line means X, Y, Z methods can be developed by well-known economist Dr. Alfred Marshall. Okay, so also means ratio method developed by Marshall. Then total expenditure method developed by Marshall. And finally, the last, C, point method of measurement of price elasticity of demand is also well developed by Dr. Alfred Marshall. Clear? One. So you write the name of that economist, Dr. Alfred Marshall. So also Dr. Alfred Marshall explained or developed two methods. First is ratio or percentage method, and second is total expenditure or total outlay method. There are two types of method developed by Dr. Alfred Marshall, but the two types of method are totally enable to measure elasticity of demand. Okay, means ratio method or percentage method, and second total expenditure method. That two types of method totally enable to measurement of elasticity of demand when they are given the demand curve, and at any level of demand curve, there are various types of the point, means A, B, C, D, E and F. So that two types of method means ratio as well as the percentage method, so does not enable to measurement elasticity of demand on demand curve at any level of point. So that's why Dr. Alfred Marshall explain or developed by third method. Its name is point method. So at any level of demand curve or at any level of any point like A, B, C, D. So and there are demand curve. So you have calculate the point elasticity of demand with the help of very simple formula. Okay. So according to Dr. Marshall, ED is equal to lower segment on demand curve below a given point, means at a given point, below at a given point upon means divided by, okay, tell that word lower and below, divided by upper segment on demand curve, upper segment on demand curve above a given point. So it is upper and above. So ED means you calculate the elasticity of demand with the help of point method. This means point elasticity of demand is equal to, that is the very simple formula are there. And so with the help of this formula, how to measure the price elasticity of demand with the help of point as the geometric method. So once again, point method is also known as geometric method. Okay, so point method is also well developed by Dr. Alfred Marshall. Okay, so Dr. Alfred Marshall also developed two types of methods of measurement of price elasticity of demand. So first is ratio or percentage method, and second is total expenditure method. There are two types of method, means ratio and total expenditure method are totally unable or totally helpless to measure the price elasticity of demand where they are given any point on the demand curve. They are given any point on the demand curve. So that's why you have measured the price elasticity of demand with the help of point method. Any point, that's why, any points on demand curve, that's why Dr. Alfred Marshall developed the third method of measurement of elasticity of demand. Its name is point or geometric method. So at any level or at any level of given the point on demand curve, elasticity of demand can be measured with the help of this formula. So which formula? This formula. What is the formula? ED is equal to lower segment on demand curve below a given point. Okay, lower segment on demand curve below a given point divided by upper segment on demand curve above a given point. Can I explain that? Okay, so once again, ED means point elasticity of demand is equal to lower segment on demand curve, lower segment on demand curve below a given point, okay, divided by upper segment on demand curve above a given point. So with the help of this, so in simple is equal to lower segment on demand curve below given point means L upon U. That is a very simple formula. L upon ED is equal to L upon U. So what is the meaning of L? Lower segment on demand curve below a given point upon upper segment on demand curve above a given point. So L upon U. So according to Dr. Alfred Marshall, with the help of point method, measurement of elasticity of demand. So in this method, there are two types of elasticity of demand. So first is linear LR, linear demand curve. Okay, linear demand curve, and second is the non-linear demand curve. Okay, so here measure the elasticity of demand with help of point method, and in point method there are two sources. The first is the linear demand curve and second is the non-linear demand curve. So in this linear demand curve, so we have measured the point elasticity of demand with the help of very simple diagram. Okay. So first look at the so how many subtypes of point method to measure elasticity of demand? How many? There are two methods. The first is linear, when there are linear demand curve, and second when there are non-linear demand curve. It's linear demand curve and non-linear demand curve. So first, linear demand curve. So how to calculate the elasticity of demand? With the help of linear demand curve. Okay. Y, O, and X. Okay? Y, O, and X. This is the linear demand curve. Which curve? This is the linear demand curve, and its name is A and B. So y-axis indicate price in bracket rupees, and x-axis indicate quantity demanded. Quantity demanded. Okay, so this point and also this point. So there are 5 points. Okay. How many points are there? 5 points are there. So you measure that point are on linear demand curve, and you have measured each and every point's elasticity of demand with the help of that formula. Which formula? So ED is equal to lower segment on demand curve below the given point divided by upper segment on demand curve above the given point. It means the L upon U. Okay, so in this point ED is equal to infinite. Okay, in this point ED is more than 1. Okay, so in this point ED is equal to 1. Okay, name that point. So P2, then P, then P, and then so in this point ED is infinite. Okay, so in this point on point P2 ED more than 1. At point P ED is equal to 1. Okay, and at point P1 ED less than 1. Okay, and at point last point ED is equal to 0. So there are calculate the 5 types of price elasticity of demand, and to how to measure that 5 types means the perfectly elastic demand, perfectly inelastic demand, third one is the unitary elastic demand, fourth is the relatively elastic demand, and fifth is the relatively inelastic demand. So at point that first point ED is equal to infinite. Then at point P2 on demand curve means AB is the linear demand curve. AB, look at AB is the linear demand curve, and on demand curve there are 5 points are there, means 1, 2, 3, 4 and 5. And so you have measured the each and every points price elasticity of demand with the help of point method, and in point method with the help of linear demand curve. Which demand curve? Linear demand curve. And so AB is the linear demand curve, and on demand curve there are 1, 2, 3, 4, 5 points. So at point A there are ED is equal to infinite, and at point B ED is equal to 0. And at point P2 ED more than 1, at point P ED is equal to 1, and at point P1 ED is less than 1. So how to calculate the elasticity of demand with the help of this diagram? Okay, so first we have calculate the elasticity of demand of P point on demand curve. Which point? Point P. So ED. So first ED is equal to PB, look at that, PB means PB lower segment on demand curve, lower segment on demand curve, okay, below at a given point, PB upon PA, it means the formula is L, it means L upon U. L means lower segment on demand curve below the given point, and U means upper segment on demand curve above the given point, means PB divided by PA. Okay, PB divided by PA. So Dr. Marshall assumes that so AB is the linear demand curve, and so its length is 8 centimeter. Its length is 8 centimeter. Means AB is the linear demand curve. It is only assume that. So AB is the linear demand curve and its length is 8 centimeter. How many centimeter? Plus 2. Means 2 plus 2 is 4. Plus 2, 6 and plus 2, 8. So 1, 2, 3, 4, 5. So AB, the length of AB lines means linear demand curve's length is 8 centimeter. Only it is assumed that. So AB is the linear demand curve and its length is how many centimeter? 8 centimeter. So this portion shows 2 centimeter, it's 2 centimeter, it's 2 centimeter, it's the addition or summation of all points is equal to 8 centimeter. Okay, so PB ED is equal to PB upon PA means L upon U. Okay, L upon U. So how many? So PB means 2 plus 2 is equal to 4. Okay, so that portion shows 2 plus that portion shows 2 plus 2 is equal to 4. Also PA means that is the upper segment on demand curve. Okay, so above the given point, from point P to A. Which point? From point P to A. Also same length. 2 plus 2, 4. Okay, means 4 upon 4 is equal to 1. Okay, 4 upon 4 is equal to 1. So in this point means at point P, elasticity of demand is 1. At this point, ED is equal to 1 and it is called as the unitary elastic demand. It is called as the unitary elastic demand. Okay, and then second. So you have finished to measurement of elasticity of demand with the help of point method. Okay, so clear. So ED is equal to PB upon PA. So its length 2 plus 2 is 4 length. 4 upon 4 is equal to 1. So ED is equal to 1 in bracket unitary elastic demand. So second 2 at so first complete. Then we have measured ED of P1 point P1. Here is the ED of point P and here is the ED of point P1 means ED is equal to ED is equal to, okay, you use the formula L upon U. L upon U. So L P1 upon B. P1 upon B. Look at that portion. P1 upon B divided by P1A. Our portion. P1A. Okay. P1A. So is equal to. So P1B, its length is only 2 centimeter. How many centimeter? 2 centimeter. P1B and above divided by P1A. 2 plus 4 plus 2 is 6. Means 2 plus 2 is equal to 6. So 2 upon 6 is equal to 0.33. Okay. Look at once again. So at point P1, so ED is equal to P1B, that is the lower segment, and P1A, that is the upper segment. So what is the length of P1B? P1B, that length is 2 centimeter. And what is the length of P1A? 2 plus 2 is equal to 4 plus 2 is equal to 6. And answer is 0.33, and 0.33 is less than 1, smaller than 1. So here is ED. ED is equal to, look at that, less than 1. It is known in other language as relatively inelastic demand. Relatively inelastic demand. Clear? So second and third. So first complete at point P, complete at point P1 complete. Okay. Then point you have measured the point P2's elasticity of demand on the demand curve. So ED in bracket, which point P2 is equal to, okay, use the formula L upon U. What is the lower segment on demand curve? Below the given point P2. Look at P2B. Okay, P2B, that is the lower segment on demand curve. Okay, P2B, okay, P2B and divided by P2A. P2A. Look at that. So at point P2, so that portion P2B divided by P2A. So what is the length of this segment? Okay. So P2B 2 plus 2 is equal to 6. Means its length is 2 plus its length is 2 plus 2 6. Means P2B 6 centimeter upon P2A only 2, so is equal to 3. Means 2 ones are 1, 2 twos are 4, and 2 threes are 6. So answer is 3. So answer is 3. It means that answer means ED more than 1. That answer 3 is greater than 1, more than 1 answer. So here is relatively elastic demand. Means more than 1. P2. Okay, so what is the formula? P2B upon P2A. And so okay, and this point, find book 4. At point A, ED is infinite. At point A, ED is infinite. So at point A, ED is infinite. It is called as the perfectly elastic demand. It is called as the perfectly elastic demand. So in that point A, ED is equal to infinite. That's why it is called as the perfectly elastic demand. Why? Because at that point, upper segment is zero. Upper segment is zero. That's why at that point, ED is equal to infinite, and in standard language, it is known as perfectly elastic demand. Is it known as perfectly elastic demand? And so last point B. Last point B. At point B, ED is equal to 0. So it is called as the perfectly inelastic demand. Perfectly inelastic demand. It is called as ED is equal to 0. Means in point B, ED is equal to 0. Why? Because at that point also lower segment is 0. Lower segment is 0. That's why at point A is ED is equal to infinite, because upper segment is 0, and at point B ED is equal to 0 because the lower segment is 0. That's why at point A the elasticity of demand is infinite. It is called as the perfectly elastic demand. And at point B, ED is equal to 0. It is called as the perfectly inelastic demand. So there are covered the 5 types of price elasticity of demand, and to measure the elasticity of demand of each and every point on demand curve. Which demand curve? It is AB is the demand curve, and it is called as the linear demand curve. It is called as the linear demand, that DD demand curve. Okay, you mean y-axis, that demand curve, that line, which line? AB line. So meet y-axis on point A and x-axis on point B. Okay, so you use the formula to calculate that diagram's point, and to calculate L upon U. So ED is equal to L upon U, means lower segment on demand curve below the given point divided by upper segment on demand curve above the given point. Okay, so there are 2 types of measurement of elasticity of demand with the help of point method. So you have measured first types with the help of a linear demand curve, and next one is the non-linear demand curve. Okay, linear demand curve. In this demand curve, so it can be explained with the help of this formula. In this formula, which formula? ED is equal to L upon U. And so you use that formula, and that formula explanation covered into this diagram. Okay, so in the diagram, y-axis indicate the price of commodity in brackets rupees, and x-axis indicate or represent the quantity demanded. Then finally, y-axis indicate the price of commodity, and x-axis indicate the quantity demanded. Okay, so in this in the diagram, so AB is the AB is the linear demand curve. Okay, and that curve meet both axes as well as y-axis in point A and x-axis in point B. So there are 5 points: 1, 2, 3, 4, and 5. So how many points are there? There are 5 points. And so according to Dr. Alfred Marshall, so AB is the demand curve, and the length of that demand curve is 8 centimeter. It is only assumes that. So AB demand curve's length is 8 centimeter. Means this portion shows 2 centimeter, 2 centimeter, 2 centimeter, 2 plus 2 4 plus 2 6 plus 2 8. Its length is 8 centimeter. Only assume that. Okay. So how many points on demand curve? There are 5 points. So 1, 2, 3, 4, and 5. So at point first, ED is equal to infinite. At point P2, ED greater than 1. At point P, ED is equal to 1. At point P1, ED smaller than 1 or less than 1. And finally, in point B, ED is equal to 0. So here use the formula to calculate the elasticity of point P2, point P, point P1, point B, and point A with the help of AB linear demand curve. So here use the ED is equal to L upon U. L upon U means L upon U means lower segment on demand curve. Lower segment on demand curve below the given point divided by U means upper segment on demand curve above the given point. It is called as ED is equal to L upon U. Okay, so you have measured the point P's electricity of demand on demand curve. So ED means electricity of demand of point P is equal to PP, that is the lower segment, PB upon PA, that is the upper segment on demand curve, above part and below part. Okay, so means PB upon PA is equal to. So what is the length are there? 2 plus 2 is 4 upon 2 plus 2 is 4. 4 upon 4 is equal to 1. So at that point, means which point? Point P shows the electricity of demand is 1. So it is called in any other language. So it is called as in that point. So electricity of demand is means unitary electric demand shows ED is equal to 1. Okay, and then second, so you have measured the ED of point P1. So ED of point P1 is equal to P1 upon B, means P1 upon B divided by P1A, means P1B upon P1A. P1B upon P1A. So what is the length of P1B? P1B only 2. There P1A 2 plus 2 plus 2 6. So 2 upon 6 is equal to 0.33. So here is the electricity of demand is less than 1. Then it is called in any other language, it is here is at point P1 there are relatively inelastic demand, means ED is less than 1. Okay, and in point third, so which point? Point P2. So point P2 on demand curve, you have measured that point's electricity of demand. So the formula is L upon U. So point P2's ED is equal to point P2 P2B, lower segment, divided by P2A, divided by P2A. So that point P2B divided by P2A. So what is the name? 2 plus 2 plus 2 is equal to 6 upon, and P2A 6 upon 2 is equal to 3. Okay, so look at that. At that point ED is more than 1 because that point, because 3 is the greater than 1. That's why in this case at point P2 there are relatively elastic demand is greater than 1. Okay, at point O, look at this point A and point B shows, point A shows that there are elasticity of demand is infinite, and point B shows there are elasticity of demand is 0. There is the infinite. Infinite means perfectly elastic demand, and 0 means perfectly inelastic demand. So at that point A, ED is infinite because of there are 0 means there are 0 segment. Okay, which segment? Upper segment is 0 and here is lower segment is 0. That's why at point B is 0 and at point is infinite. So my dear students, today we have finished the methods of measurement of price elasticity of demand. So tomorrow we will be start the second section of calculate or measurement to price elasticity of demand with the help of non-linear demand curve. Thank you.